So the last small topic with partial derivatives I want to cover is how do we get the total derivative, or the total, what's sometimes called the total differential. So we can find the partial derivatives of individual variables, and that's often all we need, and that can be quite useful. But sometimes we know what's the total derivative, right? If you want to find the derivative, not just a partial derivative, but the whole derivative, how do you do that? And you use partial derivatives to find the total derivative. So let's stick with our, basically you add up the partial derivatives in each variable. So let's stick with our example of the ideal gas law. We could do this for more complicated things like the van der Waals equation, but we'll stick with the ideal gas law. If we want the total differential, we write that as dp without the, not like this, right? That's the partial. And by definition, the total differential is equal to the partial derivative of p with respect to t, holding v bar constant, times dt. And then, right, so this is going to match up here. And then we take the partial derivative of p with respect to v bar at constant t times dv bar. And that gives us the total derivative. So we can actually go ahead and plug in value, like plug in the equation here. We already solved these, so we could say dp is equal to dp dt at constant v bar, which is r over v bar. So we'll get r over v bar dt plus dp dv bar at constant t, which gives us minus rt over v bar squared dv bar. And this would be the expression that tells us the total derivative. And we're going to have these terms with dt and dv bar because our derivative is going to depend on both. Total derivative is going to depend on both of these. If we have more variables, we just add more terms. We'll see later in the class, we'll get functions that look, we'll have this thing called a partition function. Don't worry about what it is right now, but it'll depend on number of particles, temperature, and volume. And then we could say dq is equal to dq dn at constant t and v bar times dn plus dq dt at constant n and v times dt plus dq dv at constant n and t dv. Right, so this is how you would write it out. And then you would need to know the expression for q to actually find the overall expression. So that is the basic idea behind how we find a total differential. And we'll use this idea of total differential. This will show up quite a bit. And allow us to relate these partial derivatives to actual physical quantities that we can measure.